Hey everyone, we got some requests to see the dogs again, so Sophie's going to be here with us for this video about ammeters and voltmeters. This should be a quick one, no equations along with these tools, just an introduction of how they're used. But you may already know if you use them properly for those simulation labs. Ammeters and voltmeters are just tools used to measure some of our readings in circuits. As you might expect, the ammeter measures amps, so it measures current, and the voltmeter measures volts, so voltage. The only real we have to be careful about how these tools are used in the circuit, though, so they can properly take their respective measurements. And as they are making these measurements, they don't affect circuits in any way. They're just, again, tools to take readings. They don't actually change any aspect of the circuit. That wouldn't be a good tool to take a measurement if it actually changes the thing you're trying to measure. So let's just talk about the ammeter first. The ammeter, as I said before, measures current in amps. So if you want to think about how to properly use an ammeter, or just think back to your simulation lab, an ammeter is a tool that must be directly placed inside the circuit, almost like it's a resistor itself. It needs to read the electrons going through a wire. It needs to read their charge specifically. So that means the way you hook up an ammeter is to hook it up in series with a circuit. I'm going to put you down now. If you think about Kirchhoff's equations, the I equation for series circuits, it says the currents, the I's, are all equal to each other. And since that's the case in series, you would want to put an ammeter in series with any component you want to read the amps through. You put an ammeter in series with the battery, you're reading the battery's current. If you put it in series with a resistor, it'll read the resistor's, the current going through any resistor. The reason ammeters do what they do is because they themselves have zero resistance. If you place a tool that has resistance within a circuit and you're trying to read current, you're immediately changing the current by placing that tool in there. So the ammeter does not have any resistance, so it can actually read the current as if it wasn't affecting the circuit at all. All right, so now the voltmeter. Voltmeter, you might remember in the simulation, was that tool with those two arms that you connected one to the other, or rather one needle to one end and one needle to the other end of a component you're trying to read the volts across. Just remember, voltage is also known as voltage drop. There's an electric potential difference between one point and another, so you need 2 points of contact for a voltmeter to work. And that's got to wrap around the part of the circuit you're trying to measure. So one needle before, one needle after. If you think about Kirchhoff's voltage rules for parallel circuits, where in parallel circuits the voltages are all equal, that's the way you want to hook up a voltmeter in parallel, so that going across in parallel to a component, it's going to read the voltage, since it'll read an equal voltage to the thing you're trying to focus on. And again, you don't want to actually affect the circuit when you take this reading. So if we connect something in parallel and it itself has resistance, it's like we're adding another resistor in parallel to the circuit. If we allow this tool to have zero resistance, like the ammeter, then it will draw much more current and again change the current that you want going through the circuit. So the voltmeter instead has infinite resistance, so it's still there, but it's not allowing any current to go through it, so it's able to read its voltage without changing the circuit. Let me show you a picture of both of these tools at once within a circuit. This is an extremely simple circuit. We've got one battery and just one resistor here. We've got the ammeter hooked in over here. By the way, I didn't mention, but you can see in the pictures. The ammeter and the voltmeter are just represented as circles with an A or a V inside. But again, we can see the ammeter hooked directly in series with the resistor, meaning it's in the same pathway of wire. This is the actual flow of electrons, the flow of current in this circuit. The voltmeter down at the bottom is wrapped around the resistor, so it reads the voltage both before and after the resistor so that it's able to read that, again, potential drop. That's what voltage is. The difference in volts before and after, because the voltage was lost pushing through that resistor. Ammeter has zero resistance, so the electrons freely flow through, don't disrupt the circuit. The voltmeter has infinite resistance, so the electrons don't decide to go one way and then another when they encounter either of these junctions. So again, the voltmeter is in parallel, but it does not draw any current through itself. The ammeter is in series. It allows electrons to flow freely through them and not disrupt the current. That's it about ammeters and voltmeters. I'm showing you just one more picture here. More complicated circuit. This is a parallel circuit. Here's our battery. Here's our resistor, and here's a second resistor. There's a couple of switches in here as well, but we can pretend they're both closed. We've got an ammeter here, second ammeter, and a third ammeter. And then we've got one voltmeter. Just try and think about what measurements each of these tools are going to read specifically, not just voltmeter reads voltage and ammeter reads amps. Specifically what? As if you were looking at one of those circuit charts. The voltmeter here is going to read the voltage across the battery. That's what it's directly reading. Now, if you take that further in a parallel circuit, the voltages are all equal in parallel. So by you taking this reading with this voltmeter across the battery means you're simultaneously solving for the voltage here and here, but that's only because it's a parallel circuit. If it were a series circuit, that wouldn't be the case. We've got an ammeter over here. This ammeter is in series with the battery. So this ammeter will read the currents directly feeding into or coming out of the battery, whichever way you want to pretend the current goes. These ammeters, A number 1 and A number 2 here, are only reading the current feeding into their respective resistors. Again, this is a parallel circuit. So let's say the current's going to the right first, out of the battery. Current comes in, goes through this ammeter. We read the total current, but then when the current hits this junction, some of it will go this way, and some of it will go this way. So the currents we're reading through these ammeters are each less than the total. Each of these currents put together will make the total. This is just a reiteration of the parallel circuit current equation. Here's everything I just said in text. If you want to look over this yourself later, there is an exit ticket to take a look at about ammeters and voltmeters, but just realize that you can use these tools like you did in the simulation labs to directly measure specific parts of a circuit. So if we were looking at this picture and we had a chart about it, VIR, resistor 1, resistor 2 total, this ammeter in the picture called ammeter number 1 would read I1, the current going through resistor 1. This one would read the current going through resistor 2, etc. So these tools are able to fill in the gaps in our chart, which is exactly what I had you guys do in your simulation assignments. If you remember, I gave you feedback on those circuit simulation assignments, and I said something like, you did it all wrong, or you have an error here or here. Go back and check that you've used these tools properly. Voltmeters in parallel, ammeters in series, and you've got to be careful where you place it, especially in parallel circuits, these ammeters. If I took this ammeter and I placed it, say, over here, well, this would read the total current again. This is before the current splits. So you've got to make sure it's in line. As close to the component you're trying to read as possible would be my recommendation for the ammeters. Hopefully I've explained this well enough, and hopefully you already knew enough of this just by using the tools yourself in the simulation. But try out the ticket, and I'll see you in the next video. Take care. Until then.